This is section 12, measures, same section as was per the foundation course. So what I'm going to do is avoid section 12.1, accuracy of measurements. I've done the videos for the foundation course. Just click on the link and look at those. It's grade C, not to be sniffed at, but I don't necessarily want to repeat myself. So I'm not doing 12.1. I'll do some of 12.2, compound measures. This links into a different section of chapter 12 of the foundation course, but they still have a section on compound measures. So it starts at grade C and goes upwards. I'll take a grade B question on page 182, and the first grade B question talks about a rock with a certain volume. Here we go. So let me just read it actually. This is question 10. It says a rock has a volume of 35. Put a volume here. Volume is 35 centimeters cubed worth of space. That's its volume. And it has a mass of, so that's little m, has a mass of 266 grams. And we've got to work out the density of the rock. Well, you may recall that the density of a material is the mass of the material divided by the volume. So we just substitute mass and volume. So mass 266 grams divided by 35 centimeters cubed. Punch that into our calculator. 266 over 35 gives us 7.6, and please note it's grams per centimeter cube. That's what we measure density in. Well, one of the units of density anyway. So that's that one. So this random rock has a density of 7.6 grams for every centimeter cube. Essentially, if I had a centimeter cube of that particular rock, it will have a mass of 7.6 grams. Alright, I'll do question 11 as well. So that was question 10. I'll do question 11 down here. The density of gold is, so here's a density, the density of gold is 19.3 grams for every centimeter cubed of gold, and a gold bar has a volume of 5 centimeters cubed. Question, what is the mass of the gold? Alright, so let's just quote the formula. Density equals mass divided by volume, and I'm working out what the mass is. Let's just rearrange it. I'm dividing by volume, take the volume over and multiply. So mass equals density times volume, substitute appropriately. 19.3 grams per centimeter cubed of material multiplied by the volume of material, in this case the gold, 5 centimeters cubed, and we'll get an answer of 19.3 multiplied by 5. That gives us a mass of 96.5 grams of gold. That's that. Grade B. Question 12 is also a density question involving 4 different materials, and we do exactly the same procedure and identify the material in the table. There's nothing new to teach there or to learn. Question 13 claims to be grade A. It's very, very easy, but I'll do it anyway. I've got here the diagram shows a prism with a trapezium as its cross section. Alright, so what I've got is, let's just turn over the page anyway. Got a trapezium, it looks a bit like that. So that's a trapezium, isn't it? You know, these are parallel lines. But it's a 3D block, so it's a prism type thing. In fact, it is a prism, and there it is. That's me drawing freehand. I'm quite happy with that. I did rather well. Anyway, these are the measurements. I've got 4 across the top. I've got 6 along the bottom. I have a vertical height of 5. These are all in centimetres, by the way. And it goes in 10 centimetres deep into the screen there, off into the horizon over New York. So, and it's been broken up for us into 3 parts. So part A says work out the volume of the prism. Well, you should recall that the area of the trapezium will be the area of this front face here multiplied by the depth or the length going into the screen. So if you remember, the area of the trapezium is going to be half A plus B multiplied by H. Well, that's like the A, that's the B, and there's the height. Just do that bit first. So I've got a half of A plus B, so it'll be 4 plus 6. Multiply that by the height of 5. What have I got here? 10. 10 times 5, 50. Half of 50, 25. So I've got 25 centimetres squares worth of area. Now we're going to work out the volume. Well, it's going to be the area of the cross section which is 25 centimetre squares, multiplied by the length going inwards as shown there, multiply it by 10 centimetres, as you can see, power of 1 and a power of 2 gives us a power of 3, hence volume is 3D. Rub that out and make that a little bit nicer. So that's like a power of 1, isn't it? Altogether, so I've got a volume of 250 centimetre cubes of trapezium. Now, or rather, a prism based upon a trapezium. That's that. Now the prism is made of pure gold. Oh wow, okay. Let's just do this, pure gold. And gold has a density of 19.3. Oh, there it is again, using gold again. So I've got density equals 19.3 grams for every centimetre cubed worth of prism. Find the mass of gold. Okay, so density equals mass divided by volume. Rearranging, I want the mass. So mass equals volume times the density. Volume just works it out, 250 centimetre cube, and the density has been given to us, 19.3 grams for every centimetre cube of gold. And now we go multiply that out. It looks like it's going to be quite heavy, isn't it? Anyway, 250 multiplied by 19.3 gives me an answer of, yep, 4,825 grams of gold. We can call that 4.825 kilograms. Right? Didn't ask me to put it in kilograms, but we can anyway. And by the way, it's not approximately equal to, it's exactly equal to, because I've not rounded it at all. Right? Had I rounded it to maybe 1 decimal place or 2 decimal places, then I have to say it's approximately equal to. But that's essentially it. Lovely question. I think I'll do question 15 as well. I might pause and just see how long the video is and then get back to you. If these get too long, then obviously we need to stop and break it up a little bit. I'll do John first and then pause and see how long it is and then get back to you. So this is John, question 15. It's the first one of these problem solving things. So here we go. John runs 9 kilometers per hour for 40 minutes. So he's running 9 kilometers per hour. Remember, it's a compound measure, distance over time, and this is for 40 minutes. That's what he's doing. And then he walks. He's walking a distance of 22.5, to make it look clearer, 2.5 kilometers in 30 minutes. Not in 30 minutes. It's me thinking ahead to the minutes. In 30 minutes. Question: what is John's average speed in kilometers per hour? Okay, well it's total. Let's have a look here. He runs 9 kilometers per hour for 40 minutes. Alright, let's work out a distance first of all. Well, I know we got this distance in that time, and I know we have this time, but we've got to actually work out how far John has gone first of all. So here we have distance equals speed times time. Okay? You may recall the speed equals distance divided by time. Well, I've just rearranged it for you. So here we go. How far did John go when he was actually running at 9 kilometers per hour? Let's see how far he went first of all. So speed is 9 kilometers per hour, and he ran for 40 minutes. Please note, 40 minutes is not 0.4 of an hour. You know there's not 100 minutes in an hour. So let's just do this then. 40 minutes will be this fraction of an hour. There we go, 40 out of 60. As you can see, that is in fact 2/3. Just cancel that as well. So John is running at a speed of 9 kilometers per hour for 2/3 of an hour. That is 40 minutes. So let's just grab the machine. Don't think we need to do it actually. 3's into 9 go 3, 3 2's are 6. He actually did 6 kilometer run over 40 minutes. Right, let's just combine the two. The average speed, well, what did he do? John did 6 kilometers and 2.5 kilometers. So we're going to have total distance is going to be 6 plus 2.5, which is 8.5 kilometers. And the total time, what did he do? He did 40 minutes plus those 30 minutes up there. So he did 70 minutes in total. Now 70 minutes is, let's do it this way, 70 over 60 hours. In other words, it's 7 over 6 hours, or 1 1/6 of an hour. I'm not sure which I'm going to use yet. 1 hour and 1/6 of an hour altogether. But I know that speed equals distance over time, but it's his average speed now. Equals his total distance divided by the total time taken. Distance 8.5 divided by 7/6 of an hour. Now if you remember how to divide fractions, you just flip this other one the other way around and just multiply. So it'll be 8.5 times 6/7, and off we go. Grab a calculator. Let's just do that. 8.5 multiplied by 6 divided by 7, that gives us 7. Let's go to one decimal place. 7.3 kilometers per hour. It makes sense. He was running, at a faster speed. He was then walking at a much slower speed. Therefore, his average speed would be somewhere in the middle. So there we go. 7.3 kilometers per hour. I just want to pause there and just check how long the video is, and maybe do just a short one to finish off 12.2. Get back to you quite soon.